Have you ever pondered the uniqueness and intricacy of Spiro compounds in organic chemistry? These intriguing molecules, such as Spiro-2-pentane, with their peculiar corkscrew-like design, have captivated the minds of many chemists. Today, we delve into the world of Spiro compounds using visual aids like 3D models and diagrams. For example, let's consider Spiro-4, NO-NAN, a compound with two cyclohexane rings connected at a single point. We will be exploring their structural design and properties in detail, shedding light on what makes them so fascinating. On screen, you'll see a model of Spiro-4, NO-NAN, the perfect example of the Spiro compound's unique, interconnected structure. Spiro compounds are a unique class of molecules in organic chemistry, almost like the exotic species of the molecular world. Let's think of them like a pair of interlocked rings, just like a bicycle chain, characterized by having at least two molecular rings connected by a single common atom. This unique configuration is what makes them stand apart from the crowd. Its most basic form, a Spiro compound, is bicyclic, meaning it has two rings. It's a bit like if you took two donuts and managed to connect them at a single point. However, Spiro compounds can also be part of a larger ring system, like a merry-go-round made up of interlocked rings, always maintaining the defining characteristic of two rings linked through one common atom. This solitary atom connecting the rings raises a flag, distinguishing Spiro compounds from other types of molecules. In contrast, think about biphenyls like two dancers holding hands, where there are no connecting atoms, or consider fused ring compounds like decalan, which are linked by two adjacent atoms, akin to two friends standing shoulder to shoulder. Spiro compounds maintain a unique connection, not like these examples. They also stand apart from bridged ring compounds like norbornane, which are connected by two non-adjacent atoms. Imagine norbornane as two islands, connected by two separate bridges. But remember, Spiro compounds are more like a bicycle chain, with that one common atom holding the rings together. This uniqueness makes the world of Spiro compounds an interesting area of study in organic chemistry. Now, let's dive in and imagine creating a Spiro compound. Picture each molecule exhibited in line-angle representation. Here, each angle is a stand-in for a carbon atom, and each line acts as a bond between atoms. To illustrate, think of it as a complex game of connect the dots, where the dots are carbon atoms, and the lines are bonds. We'll use these representations to create a heterocyclic Spiro compound, a common structure. To put it in perspective, consider it as a sophisticated piece of art assembled from a monocyclic type of ketone, like a single ring of cyclohexanone, and an acyclic type of diol, such as ethane 2-diol. This leads to the formation of a fascinating interconnected network of atoms and bonds, forming the foundation of the Spiro compound structure. Visualize it like a precisely engineered architectural structure, with each atom and bond having a specific place and role. Remember though, looks can be deceiving. While these structures might seem two-dimensional or planar, they're hiding their true three-dimensional nature. Think of it like a pop-up book. It appears flat at first glance, but open it up and you'll see the orthogonal orientation of the two rings popping up, adding a new dimension to our understanding of the Spiro compound structure. Consider, for example, a fully carbocyclic Spiro compound. To better illustrate this point, imagine a Spiro undecane. On a first glance, might seem flat and planar, just like a pancake, but scratch beneath that surface, and you'll be astounded. With a highly populated chair conformation of each ring, it resembles a crowd at a concert, each person or atom in a unique position. And the actual orthogonal orientation they have to one another? Picture a city grid, with roads intersecting at right angles. This is the hidden complexity of molecules like Spiro undecane. In summary, Spiro compounds are unique, complex structures in the world of organic chemistry. Picture this. You have two rings, say two Olympic rings if you will, and they are connected by a single common atom, much like a hinge holding them together. This feature sets them apart, distinguishing them from other compounds, like a fingerprint sets us apart from others. Now, imagine a spiraling staircase, intricate and intertwined. That's exactly how the creation of Spiro compounds unfolds, involving intricate networks of atoms and bonds. Here's an interesting illusion to consider: a flat drawing on a piece of paper that, when you look at from a different perspective, appears to be 3D. That's how Spiro compounds can be. They might seem planar, but they are actually orthogonally oriented. Spiro compounds can be part of a larger ring system or a simple bicyclic compound. Imagine a parent and a child holding hands, each a ring with their arms. That's a visual example of a larger ring system. Now picture two children making circles with their arms, holding hands. That could represent a simple bicyclic compound. In either case, Spiro compounds are an exciting and important part of the organic chemistry landscape, like a thrilling roller coaster ride in an amusement park of organic chemistry.